Hello everyone and welcome back to my YouTube channel. Today we will discuss chemical bonding for class 11th. It is one of the most important chapter and all the chemistry is dependent on chemical bonding. So what is a bond? What is chemical bond or what is a bond? It is the electrostatic force of attraction. It is the electrostatic force of attraction that held together ions or atoms. For example, we have ions, either positive charge or negative charge. So the force of attraction that binds ions, or we have atoms. Again, the electrostatic force of attraction that binds ions or atom to make a stable molecule. And bond formation is an exothermic process. Bond formation is an exothermic process. So molecules formed are more stable than atoms or ions. Molecule formed are more stable than atom or ions. Why? Because energy is released during bond formation. Energy is released during bond formation. Right? Let's understand it with the two atoms again. For example, we have two atoms, atom number first and atom 2. Assume it is a hydrogen atom. So it contains centralized positive charge nucleus and electron. Let's see how these two atoms can combine to form a hydrogen molecule. Let's see forces. This electron and this electron will repel each other. That is Fr first. Fr first represents repulsive force first. Similarly, this nucleus will repel this nucleus because like charges repel each other. This is Fr2. But we can see there is attraction force also between this electron and this nucleus. This is Fa first, force of attraction first. Similarly, this electron will be attracted to this nucleus. This is Fa2. Attraction force second. So when these atoms can combine, when net attraction force is greater than net repulsive force. When net attraction force is greater than net repulsive force. So we can say Fa1 plus Fa2 must be greater than Fr first and Fr2. If this condition is satisfied, then atom can combine. If attractive force is higher, if attractive force is higher, then definitely potential energy will decrease. If attraction force is higher, means potential energy will decrease. There is a decrease in potential energy. As a result, stability will increase. So we can say attraction force is inversely proportional to potential energy and directly proportional to stability. So what is the first conclusion? First conclusion is attraction forces directly proportional to stability and inversely proportional to potential energy. Attractive force is directly proportional to stability and inversely proportional to potential energy. If attraction force increases, potential energy will decrease and hence stability will increase. So why elements combine, या why bond formation takes place? First reason we can say why elements combine. First reason we can say to minimize potential energy. To minimize potential energy. Second reason, to complete octet. Now what is this octet? For this we have octet rule or Lewis theory. Octet rule or Lewis theory. According to Lewis and Kossel. According to Lewis and Kossel, elements having 1 to 7 electrons in valence shell. Elements having 1 to 7 electrons in valence shell can combine with each other by 3 ways. First way, by losing electrons. Second, by gaining electrons, or by sharing of electrons. By losing electrons, or by gaining electrons, or by sharing of electrons. What type of elements? Elements having 1 to 7 electrons in a valence shell. By these 3 means they will get 8 electrons in their valence shell, and 8 electrons represents the noble gas configuration, inert gas configuration. So basically we can say why elements combine: to minimize their potential energy, to make a stable molecule. Second is to complete their octet. Octet represents 8 electrons in a valence shell. For this we have a Lewis theory given by Lewis and Kossel. Next is inert gases never combines. Inert gases never combines. Why? Because they already have their minimum potential energy. They already have their minimum potential energy due to presence of fully filled orbitals. So why inert gases never combine? Because of fully filled orbitals. They don't need any electrons to gain, or they don't need to lose electrons or share electrons. But other elements combine to achieve inert gas configuration, to become stable. Let's see. For example, we have sodium and chlorine. Sodium atomic number is 11, configuration 281, chlorine 287. So this electron from sodium is given to chlorine. As a result, stable configuration 28 and stable configuration 288 is achieved. Now it is sodium cation and this is a chloride anion, so they will positive negative charge attract each other. They will combine to form NaCl. How many electrons are loosed? Here, one electron is loosed by sodium and gained by chlorine. Second example, for example, we have magnesium oxide. Atomic number of magnesium is 12, means 2 electrons. Oxygen atomic number is 6, means 8, means 6 electrons. Now these 2 electrons are transferred from magnesium to oxygen. As a result, magnesium also becomes stable, have 8 electrons in valence shell. Similarly, oxygen become stable. So after losing 2 electrons, magnesium will be cation and oxygen will be anion. Again they will attract each other, electrostatic force of attraction will be there, and magnesium oxide is formed. This is the first way, or both ways, by losing electrons or by gaining electrons. But some elements like carbon, like silicon, like group number 14, carbon, silicon, they have 4 electrons in their valence shell. So they can't lose 4 electrons and can't gain 4 electrons. So they share electrons. For example, we have methane molecule. How does it form? Carbon contains 4 valence electrons, and we know hydrogen contains 1 electron. X here is the electron of hydrogen and dot is the electron of carbon. So now bond formation takes place. Carbon contains 8 electrons in its octet, in its orbital, so it is stable. And some elements like hydrogen and lithium, they don't complete their octet, they complete their duplet. Duplet means 2 electrons in a valence shell, means they achieve the configuration of a helium noble gas. So this is the bond formation, either by losing or gaining electrons or by sharing of electrons, right? What type of electrons can participate in a bond formation? Next question is, what type of electrons can participate in a bond formation? 2 types of electron can participate. First is valence electrons, second is n-1 d orbital electron, either valence electrons or n-1 d orbital electrons. And according to orbitals involved, combining capacity or valency of element is determined. Right? Those electrons which are present in valence shell and those electrons which are present in n-1 d orbitals, they can participate in bond formation, they can combine. That will decide the valency of elements. Clear? Next is a bond pair. What is a bond pair? Bond pair means electrons which participate in bond formation. Electrons which participate in bond formation, they are counted and considered as a bond pair. Opposite of this, we have lone pair. Electrons which do not participate in a bond formation. Electrons which do not participate in bond formation, they are considered as a lone pair of electrons, and electrons which participate in bond formation, they are considered as a bond pair. In a competitive exam, question may be asked how many bond pair are present, how many lone pair are present in a given compound. Let us understand. For example, we have CH3COOH. It is acetic acid. Let me represent it in electron dot structure. We know carbon contain 4 electrons. 3 hydrogens are connected, means next atom is carbon. Carbon contain again 4 electrons. But now with this carbon, one oxygen is attached and second group is OH. So these 2 electrons are shared with the oxygen. This electron is shared with the next OH group, and let's represent electrons of oxygen also. Oxygen contains 6 electrons, 2, 6. Similarly, this oxygen contains 6 electrons, 2 to 4 or 6. So this bond is shared, this electron is shared again. This bond formation takes place. Next is H. So this is CH3COOH. Let's count a bond pair. Let's count a bond pair. I think 1 bond, 2, 3, 4, 5, 6, 7, 8. We have a 8 bond pair here, and let's count a lone pair. 1 lone pair, 2, 3, 4. We have lone pair 4. So free electrons are lone pair electrons and bonded electrons are bond pair electrons. Clear? Next is a classification of bonds. Classification of bonds. Bonds can be classified according to their strength. Strong bond, weak bond. Strong bond and a weak bond. In strong bond, we can say electrons are involved, so it is a chemical bond. Weak bond is a non-chemical bond. Why it is considered as chemical bond? Because electrons participate in bond formation. Electrons participate in bond formation. And why it is a weak bond? Because electrons do not participate. Weak attractive forces are present only here. Strong electrostatic force present. On the basis of presence of electrons, these bonds are of 4 types. First is ionic bond. Second is covalent bond. In 10th you also studied ionic bond and covalent bond. Third is coordinate bond. Fourth is a metallic bond. So basically we have 4 types of bond if electrons are involved in a bond formation. And if electrons are not participating in bond formation, then bonds are of 2 types. Hydrogen bond and a van der Waals force of attraction. So on the basis of electron, if they are not participating, then bonds are of 2 types, hydrogen bond and van der Waals force of attraction. This is further of 3 types. First is chiasm force, second is Dubai, and third is London. Force of attraction. So van der Waal is again further of three types: schism, Dubai, London force of attraction. So we have the blueprint of this chapter. In next lecture we will start each and every bond with their strength, with their conditions, with their properties. So that is for today. Keep exploring my channel. Stay at home. Thank you.